Now we've finished dealing with finding equations of lines. We now need to deal with parallel and perpendicular lines and what impact that might have on our equations. So let's take a look at this follow diagram. You've got two lines that are parallel. That means they will never touch. They are constantly the same distance apart when you're looking at those two lines. If you actually look at the lines and study the gradient of each line, they're going to have the same steepness rating or the same gradient or the same slope. So M1, the gradient of line 1, equals M2, the gradient of line 2. What about perpendicular lines? Well, we've now got a new diagram. You can see the two lines are at right angles to each other. That means they're perpendicular. When you look at line 1, it has a gradient called M1. You look at line 2, it has a gradient called M2. There they are there. If those gradients times together to give an answer of -1, that means we know that the two lines cross over at right angles, they are perpendicular. If it doesn't give an answer of -1, they are not perpendicular. So let's go and try some examples. Here's our first example. Show that those two lines are parallel. Well, let's look at line 1. When we look at line 1, I'm going to use this formula. It's one that we used earlier. Because they're both in general form, I'm going to use that formula there. To find the gradient, it's minus the number in front of x over the number in front of y. So for line 1, the gradient equals minus the number in front of x, which is 3, over the number in front of y, which is -2, so it equals 3 over 2, because the two minuses cancel each other out. If I look at the second line, the gradient 2, the gradient of the second line, equals minus the a number. What's in the second line? It's -3 over -2, which is also 3 over 2. So since M1 equals M2, the lines are parallel. And there we have our answer. Let's try the next one. Oops, jump one too far. Here we go, next one. Show that these two lines are perpendicular. Well, the first line is already in the form y equals mx plus b, so the gradient of the first line is equal to -2 because it's a number in front of x. The gradient of the second line, I'm going to use this formula here. Oh, what have I bumped there? Is minus, it's interesting. I can't go up there. A over B. I can't go too high or I'll delete it. Look at that. Anyway, we're using minus A over B. I get sidetracked. Let's have a look. The second line has a gradient using minus A over B of -1, because the number in front of the x is a 1, over -2, which is a half. M1 times M2 equals -2 times a half, because I'm multiplying the two gradients together, which equals -1. So I can say, therefore, the lines are perpendicular. Okay, so let's look at example number 3. We need to find the equation of a straight line parallel to 3x take 4y plus 12 equals 0, and it passes through 2 minus 5. Now if it's parallel to 3x take 4y plus 12 equals 0, I can use the formula m equals minus a over b. So the gradient equals minus the number in front of x over the number in front of y, which equals 3/4. So I now know the gradient is 3/4. That means now I can find the equation of the line, because I have a gradient of 3/4 and it passes through the point 2, -5. So let's use our formula. Y take y1 equals m, x take x1. Becomes y minus -5, which is y plus 5, equals 3/4. X take away x1, which is 2. Now the trick here is to get rid of that fraction as quickly as possible, and to get rid of that fraction we need to multiply both sides by 4 and they'll cancel. And so effectively what we end up with is 4y plus 20 equals 3x minus 6 once we expand this bracket out. Put it into general form. I'll move everything over to the right hand side. I'll end up with 3x minus 4y minus 20, so I get minus 26 equals 0, and there is the equation of the line that's parallel to 3x take 4y plus 12 equals 0 and passing through 2 minus 5. Equation number 4, or example number 4. Find the equation of a line that's through 3, 2 and it's perpendicular to the line that passes through those 2 points. This is a time-consuming question. Now, we know it's perpendicular to the line that passes through these 2 points. So I'm going to use this formula here. Y minus y1 equals y2 take y1 on x2 take x1 bracket x take x1. Now, I've got my 2 points up here. It's y minus the y value of the first point, which is 1, equals the y value of the second point minus the y value of the first point, the x value of the second point minus 4, which becomes plus 4, and the x value of the first point is minus 4, x minus minus 4 is x plus 4. So I get y take 1 equals 3 over 3 x plus 4. 3 over 3 is just 1, so I get y take 1 equals x plus 4. Y equals x plus 5. That line has a gradient that we can actually recognise as gradient of that line equals 1. So the gradient of the perpendicular line would equal minus 1, because we know that perpendicular lines, the two gradients have to times to give an answer of minus 1, and 1 times minus 1 equals minus 1. So I can now find the equation of the line I'm interested in. I know we're going to be using a gradient of minus 1, and it passes through 3, 2. So I'll use my formula when I know a gradient and 1 point. Y minus 2 equals minus 1 minus 3. Expand the brackets out, put it into general form, minus 3 to both sides, and there is my answer. And that's it. Time to do some questions. Have fun.